Gross. Okay. I won't be able to jump around or anything, but looks like I'll be stationary. That's okay. I can just, yeah, I'm fine. Can you hear me okay? Yeah? Okay, so my name is Mike Meffie, software engineer with a small outfit called Sinonomi Associates. We're a systems system support and engineering organization based in Ashburn, Virginia, and we're a distributed company. I happen to work in North Canton, Ohio, and we have people in different locations, all telecommuting. The one thing that one of the parts of our business is supporting some open source projects. One of the things we provide commercial support for is OpenAFS, which is an open source project that IBM open sourced about 14 years ago. This is not going to, although I do this as part of my day job, this is not meant to be an infomercial. This is just basically me sharing what I know about this project so that if people here would be interested in it, just to get them started with it. Normally when I talk about this stuff, I'm already talking to people that are using this. So when I go to client sites and they're already using this stuff, and I do training, and we do training and troubleshooting and that sort of thing. So this is kind of new for me, where I'm coming to an audience and telling you guys about this. And some people here probably heard of this. Some people may. Show of hands, how many people have ever heard of AFS? Really? Okay, so Mike doesn't surprise me, but the rest, that surprises me. That's good. So, no, you guys are using ZFS, I think. No, I'm not surprised you're not using it. I'm just surprised that you've even heard of it. Excellent. No, so well, I'll get into MIT here in a bit. So back up a second. Why would you want to do this? So basically, this talk is about setting up your own. So everything's got to be a cloud today, right? And you can't sell it if it's not in the cloud. But so AFS is really, in a lot of ways, was the granddaddy of cloud file systems. It was meant to be from the get-go a distributed file system where any user from any machine could see their files, and it didn't matter where they were on which servers. And that was what it was designed to do. And this was a vision that was actually started at Carnegie Mellon University back in the late 80s. So why would you want to do this if there's so many things? You know, there's these drop boxes and whatever whiz-bang thing there is today. Well, you know, the thing is, maybe you don't want to put your files on some server that is somewhere someone else is maintaining that infrastructure. Maybe you want to have control over your data. Maybe you want to put that somewhere where you can trust the hardware that's running your file servers. Maybe you just like building stuff. This is Notacon. I assume you guys like to do new stuff or build stuff. Or maybe it's just, I don't know, just because you want to do this. So what's AFS? AFS is a network file system. So what that means is that it's a file system that looks like the files are on your computer, but they're actually on the server somewhere. It's not like a syncing program where you're syncing files using a web interface or an application to sync files from machine to machine. You're not dropping files in one location and then someone else syncing them to somewhere else. It's sort of like a shared folders mentality here. So the thing is, the files that you have, the goal is to have the same paths on any machine that you use. So if I go to any machine in my infrastructure that has the AFS client set up on it, I should be able to see the same files no matter which machine I have. And that's the goal of AFS. The idea here is that the clients themselves don't dictate where things are located. All that configuration is centrally managed through a system that we call a volume location service. So the files here they look like they're locally on your machine, but they're actually stored on the servers. However, AFS has this idea of aggressive, what we call aggressive caching of the files. So the files are local to your machine. This is the magic of AFS, where once you read a file, it's stored locally on your machine in a special cached area. And then subsequent access to that file is accessing the file on your local drive. So the idea is that AFS was designed with the idea that the fastest network message is the one you don't have to make. So we cache files locally, and then if someone on another machine changes that file, the file server is smart enough to tell the clients, hey, that file you just read changed. And the clients can go back up and get the new version. And that's all under the covers, so users don't need to mess with any of that. Yeah, so server has to maintain state in this case. So, yeah, so way back when NFS was new, Carnegie Mellon when they built AFS, what they wanted to do was they wanted to build an NFS that would scale. That was the idea. So this was a lot of the ideas that are in NFS 4 are already in AFS now. NFS 4, of course, I mean, there's a lot of differences, but there's a lot of same concepts. In addition to that, AFS provides access controls for privacy. So the thing is, if you have a distributed file system where I have people on different machines, and they all have probably different UIDs, right? So if like on one machine I might have one UID, on another machine I might have a different UID. Basically, AFS doesn't trust your Unix user ID at all. It doesn't use it, really. It only uses that to map you to a Kerberos credential, which we'll talk about. So given that, this allows you to have a system where different users can effectively have access controls on their files. So they can say who can read what files when, or not when, but who can read which files. So this allows you to set up your privacy. Another thing that AFS provides is this idea of read-only content. So we'll talk about this a little bit more later, but basically, this is one of the features of AFS that I think is pretty nice. It's one of the reasons people really use it, is files in general. When people are using files, there's different kinds of files. There's files that you're reading and writing, but a lot of files, you only create them one time. And then after you create that file, you have people just read that file over and over again, like program files, media files. So AFS provides this idea of read-only files, and it allows you to replicate those files so that if one server goes down, another server can pick up where that one left off, and you have some redundancy there. And this last bullet is what I talked about before, is that clients themselves aren't configured to say which files are on which servers. That's maintained in a central service. So who's using this stuff? So AFS was designed way back in the days by CMU. IBM created this proprietary project. They had a product called AFS. Back in 2000, they actually open sourced it. They provided a version to the open source community called OpenAFS, and that's what we've been maintaining since. People that are running OpenAFS include large finance institutions use this to store, for example, all of the, well, I shouldn't say what they store, but they store a lot of things in it. I'm not going to provide any names here, but there's information on the web if you want to look to see what they're doing. There's a large engineering, multinational engineering companies. They store a lot of information about the products that they're building. Basically, all your fighter jets and your cell phones use AFS, or the files that store those are in AFS, like the CAD drawings for those. AFS is heavily used in research institutions, like CERN is a heavy user of AFS. They've been using it since since the 90s. All the home directories for all the scientists are stored in AFS. So this provides a way for the scientists to easily share files between each other. They can set up, they have a home directory, and in their home directory is in AFS. So no matter which machine they're on, they always can see their home directory, and they can set up access control to let other scientists share files in their home directories. The Higgs boson, all the data for the Higgs boson came out of AFS. All the data that comes out of the Mars rover, that comes out of AFS. It's used for bioinformatics. Pharmaceutical companies are using it. So this stuff is used on a large scale. You guys can use it on a smaller scale. It scales down. I use it for my own personal stuff. All my photos go into AFS. This slides go into AFS. Also, there's, the government is a heavy user, and a lot of universities adopted AFS early on. This is a picture of the AFS servers at CERN. I was actually got to visit CERN. They have a very large AFS installation. Of course, they push it to its limits. And this is the computer center at CERN. And being a file system, I don't have a lot of pictures to show you, so I thought, a computer kind of cool. That's the data center at CERN. So some background. So to use AFS, actually, one of the things you need to have is so some of the things that you need to have to actually deploy this stuff. You need to have a Kerberos infrastructure in place. So that's kind of a big step up from where people are now. A lot of people aren't used to using Kerberos. It's not hard to get started on it, but Kerberos is actually a system that was developed at MIT. Some spoke at MIT. It was developed at MIT. You may already have Active Directory. Active Directory has Kerberos support. So the files themselves are stored in servers, and these just run a server process. So you need to have somewhere to run these. They can run in virtual machines. I run mine in virtual machines. They can be physical hardware. Depends on what your needs are. The clients themselves actually need a driver. So there's a file system driver. It's a open source driver. There's one for Windows. There's one for Linux, BSD, and so on and so forth. And then there's this configuration service that I spoke about. These are basically like a lightweight service it runs on a server that clients contact. So the file servers themselves, they can be any Unix variation. We don't support Windows for the servers, but we support Windows for the clients. These can be on actual machines. They can be on virtual machines. You can mix and match. We don't care about one of the nice things about AFS. It's very and one of the reasons it survived for so long is it's very OS neutral. Everything on the wire is everything is described to be compatible across architectures. So we can mix and match Linux and Solaris servers, for example. People do that all the time, and even versions. We can have all different versions running at the same time. The servers themselves store the files in file server partitions. So the back end, where the actual files are stored, they can be on ZFS, for example. They can be on ext4, XFS, whatever file system you like. So an AFS term, so when we set up an AFS site, we use the term cell. That's just the name that we use for it. If you have a set of AFS file servers and clients, that's called a cell. And these cells can work over the public internet, of course. You can run them inside your environment, inside a company or organization, or you can have them running over the public internet. So normally what you do is you set your cell up to match your domain name. So like for my cell, I have a domain meffie.org. So my cell is called meffie.org as well. And also you need a Kerberos realm. The convention is for the realm to match the cell as well. Okay, some pretty pictures for you. So you need an authentication service. So before we start using AFS, we have to have a base service in place, which is Kerberos. So Kerberos provides the way that users authenticate themselves to the system. So this isn't really part of AFS, but it has to be in place before. Like I said, this is going to be Active Directory. There's actually an MIT implementation. There's another implementation called Heimdall, which is similar to the MIT one. Basically, Kerberos provides a key distribution system. User passwords are not sent over the wire. However, you do need to have a server that is the key store for the Kerberos credentials. And this key store has the keys for every user, and it also has the keys for every service. So for example, the AFS service has a service key. It's stored in here. And Kerberos provides a mutual authentication between the clients and the services, so that when a client logs in, he gets a key to use that service. And the service basically cross-checks that the client is who he says he is, and the client verifies the service is who he says he is. So this is a very secure system, and like I said, it's Active Directory uses this as well. Another point is that if you're using this, you need to, Kerberos requires some clock synchronization. The credentials, the protocol itself requires the clocks to be within about 5 minutes. So it means your clients and your servers have good timekeeping. So after we figure out Kerberos, which isn't very hard, but you install Kerberos, you basically start setting up your keys and your users. After that's in place, then we can start setting up our AFS configuration servers. So normally you would install this using your standard apt. I spelled apt wrong, didn't I? Apt or yum. No, that's right. And there's setting up the servers are fairly straightforward. They start empty. The interesting about the database servers is that they're replicated. So typically you'll have 3 servers, database servers running. And we call these database servers, but they're not databases. That's just an old name. They're really configuration servers. They're not like SQL servers. They're very lightweight configuration servers. And clients they send queries to these servers over the network. So the servers themselves, they just run as a normal Unix process. And like I said, you normally set up 3 of them on 3 different machines, so that if 2 go down, at least 1 is still running. If 1 goes down, the other 2 will run. And they have this election process where they vote to say who's going to be the main server. And any time writes are done to the configuration, it goes to that main server, the master server. And anytime you do a write, then it's propagated out automatically to the slave servers. For setting up like a site for myself, right? I just have 1 server, but like for a larger rollout of this, you'd have 3 database servers. There's 2 kinds of database servers. There's one called a protection database. This is a database that has the list of every user, and it has a list of every group. And a group is basically like a Unix group. You can add users to a group. This is just to make setting up the access controls easier. And the volume location database maps basically all the files that are in AFS are collected into these sets called volumes, that we call volumes. And they're file sets. They're like a directory tree. And users don't see this. This is for the admins, right? When you're managing your data sets. So when a client needs to find a file, that file itself maps to a special number, an AFS file ID, and that file ID contains the file set number. So we look up which server has that file. So that's not configured on the client. This allows us to do things like move things around without having to update clients. So, setting up. So now that we have our database servers up and running, we can set up our file servers, and these can be. You can have up to about per cell 255 per cell. Of course, you can create multiple cells if you'd like. And these have dedicated partitions on them, where you can hang whatever kind of storage you need. Like it could be SAN storage, it could be direct storage. The file server doesn't really care as long as it can read and write to that area. And you can add more partitions if you need to. Over time, if you need more space, you can add more servers. So AFS is designed to scale out horizontally. As you need more space, you can just add more servers. And since we have that volume location database, you don't have to reconfigure clients when you add more servers. They automatically pick up where the new servers are. The clients themselves we install using, so it depends on the kind of what we're running. So like if it's a Debian machine, right, there's Debian packages to install, CentOS or CentOS packages. Essentially what happens is the clients themselves need a kernel module though. So the Linux client needs a Linux kernel module. And the Mac OS has the Mac OS file driver. Windows is a separate beast, but it's supported using a lot of the code is in common with the Linux code in terms of like the networking and those kind of pieces, but Windows itself is completely separate from Linux, how it deals with files, so it uses something called a redirector. There's an iPhone client that's available now. I don't have an iPhone, so I don't care. But and of course, you need to have the Kerberos client set up. So when a user, if you do this correctly, you would actually set up something called PAM, so that when a user logs in to their system, they automatically get their credentials, the Kerberos credentials and their AFS credentials. And on Mac OS, you would use whatever the Mac OS thing is. So we have access control lists to say who can do what to what files. They're pretty basic. You can say who can read to files, who can write to files, who can execute, who can do lookups. You can have multiple people writing to files in the same directory. Like, right, you can have people in different machines writing to the same directory at the same time. And if you do that, what happens? Well, the last person that writes that file, his changes would overwrite the other changes. They're like interleaved by that. It's just like if you have multiple people on a Unix box and you're both writing into the same directory at the same time. One big difference, though, is that unlike Unix and AFS, file updates aren't done until you close the file. So the intermediate writes actually are going to a local disk, and when we close the file, they're flushed out to the server. So that's one thing that's not POSIX. And I mentioned already we have these things called volumes. So from a user's point of view, they don't. It's just like a directory structure. They don't really see these, but from an admin point of view, we need to somehow manage all these files, and so we group them into these basic into a file set. And a file set has a single we call a root vnode or root directory, and then it has files and subdirectories under there. And one of the cool things about AFS is that once we have these volumes, one of the things is we can manage things by volume. So when we create a new space with an AFS, we create a new volume, which basically sets up that volume location, where the volume is located, which server, and then people can start putting files in that volume, and then we can do things like move that volume around even while people are using it. So like, for example, if you have a server that's really, maybe you need to retire a server, for example, we never have to take any downtime. We don't have to do it in the middle of the night when no one's using it. We just move the volumes off to a different server, and we can do that during the day while people are using it. And then once all the volumes are off that machine, we can do whatever we need to do. Or you can move volumes around if you need to balance space or something like that. So this is something that people do all the time with AFS. They can move volumes around even while they're in use. Another interesting feature of AFS is the read-only space. So a really important case for files is things like program data. That's not stuff that's supposed to be changing, right? At CERN, when they grab the data out of the LHC, they stuff it into a file. You're not supposed to change that file ever again. So it's like a write once file. Movies are kind of like this too, right? You have an MPEG or whatever. You have media. So there's a lot of cases where people have files, you create that file, and after that you never need to write it again. You just want to read it again. And maybe you have a lot of different people who need to read that file. Maybe you have to distribute that file over to 100,000 different machines. And when you distribute that file to all those machines, you want to make sure that they all get the same file at the same time. so that they're all updated atomically. This is really important for programs, right? If I have a program that's our systems are running and we need to update this program, I don't modify that program. Basically, I just give it a different version number, so I give it a different file, but I have to distribute that everywhere. So what AFS does is it has this idea of read-only replicas. So you have a volume, which is the read-write volume, and then you have these subvolumes that are hanging off this read-write volume, and these are called read-only clones. And so when the data is pushed into the read-write volume area, there's a command that we have, that AFS has, that you run this and it makes a snapshot to all the read-only clones. And then that snapshot is pushed out to all the servers, and then the clients are updated when they're ready. After they've been moved out, the clients are notified that the new files are ready. And so they all get, there's an atomic switch from the old to the new. So this is a critical feature of AFS. So it's used a lot for, this is why AFS is used a lot for managing read-only content, like program content, web content, or things that it's not dynamic. Another important point about the read-only file replication is that you can have multiple sites. So I can have, like, say, 10 copies of this and other file servers. If one of them goes down, then the clients will notice and they'll fail over to the other ones. They'll try different ones. So there's a delay there, of course, during the failover, but then eventually you get to a server that's working, and then you can read your files. So some nice things I think about this software is it's open source. You guys have the code. You can send us patches, please. You can. There's no charge to start using it. We support a wide range of platforms. Something I didn't mention before is an idea of global namespace. So AFS was designed to be something that universities use over the internet. So the idea is that there's there's like a hierarchy that everyone can use on the internet. So you can have /AFS / your domain name, and then under that is where you put your files. So like there's a /AFS / MIT / CERN / there could be a /AFS / Notacon. So there's there's a global namespace that everyone can see. This allows people to share files, even within different cells. So it's like an idea of creating a federated system of files. We talked about location transparency already. This is where clients can, you don't have to configure clients when you change what files are on which servers. Client-side caching. This is where the files are actually stored locally on clients so that they can read quickly. They can read or write the data, or read the data quickly. And of course, there's a bunch of bad things too. I've just listed. I didn't want to spend too much time on this, but so AFS, because it's such an old system, and because we are very ardently backward compatible, so that you can run like a modern AFS file server and it would still work with old clients, and vice versa. So there are some really ancient, strict limitations that will bite you. For example, you can only have a maximum of like 64,000 files per directory, theoretical maximum, which will break for some use cases, and that's something that needs to be fixed. But to do that would break compatibility, so it hasn't been fixed yet. Network performance is not what we want it to be. Everything on AFS is currently still using UDP. We have a TCP data transfer feature, but it's still experimental. It's only being used at one site right now. But you're welcome to try it if you want to use it. Another problem with AFS currently is that it has the native cryptography that's used between the file server and the client is very weak, unfortunately. And there's work in progress. Actually, there's a person at MIT that's actually developing something called a GSS API security class for AFS. This will allow us to have very strong encryption for the data, for the packets going back and forth between the client and server. As it is today, if you're using this and you're using this over the internet and you're concerned about security, I would recommend OpenVPN or something to encrypt your packets. If you're inside of an organization, you're not sending packets over the network, then maybe that's not such an issue. Oh, and I suppose if you're sending like data, if it's data that's not private, then that's not an issue as well. Another pain point is that the Linux kernel module is out of tree. So the code that we have for AFS is licensed under the IBM public license, which is not compatible with the GPL. And even if it was compatible, I doubt that the kernel developers would take it because it's a completely different style than the Linux kernel code. But that could be an issue for sites that don't want to run out of, this is for the clients only, not the servers. But for a client, you need to have this out-of-tree kernel module. And a client could be, in this case, could be a web server, for example, if you're serving web data over AFS. So that could be a problem. There is actually an in-tree AFS client, but it's still a work in progress. It's considered experimental. And this last bullet is NAT pain. So since this is all still using UDP, things like using AFS at conventions is hard because we go through a NAT here. Like all these slides are in AFS, but sometimes I'll see hangs, like even here, because a lot of NATs aren't set up to deal with UDP traffic correctly. And also routers cannot deal with UDP traffic correctly sometimes too. They're just been optimized for TCP. So that's my slide deck. I'll open the floor to questions if there are any. Yes? Oh, there's only one that is stuck here.
Can you repeat the question?
I can repeat the question. Go ahead. Okay, so the question was, if everything goes wrong, if we lose all those servers, and can we get to the cache data? So the answer is no. But specifically, so the cache, you can get to the cache data, but that's not going to help you really. What you need to do is, so AFS has this idea of, so you want to back up your data, right? You're talking about for disaster recovery. There's two things. One is for data that is like, especially you can always replicate data, like especially for read-only data, even for read-write data that you don't care that people. You can use the replication system to put data in multiple places, so that if you lose one server, you have the other one. And we have this thing called convert read-only to read-write, so you can pull it back. But really what you want to do is back up your data, right? So what you do, AFS has this system for extracting all the data out of the file servers and putting it in this special format that's like a tarball format. And it saves the data, all the metadata, and all the access controls in the special format that you can parse out later if you want to pull out specific information. So that's what sites normally do is they run a job, like a cron job, that goes through and says what volumes have changed recently, and then store those backup that backup information. The cache itself is considered scratch area. Any other? Yep.
As far as the caching goes, how can you limit or control the caching so that you get out of hand if you start downloading some larger files?
So the cache itself is. Oh, sorry. Thank you. So the question is, how do you keep the cache from taking over your machine, basically, right? Because if you have, like, say I'm downloading movies, and it's going to soak up my entire system. So, yeah, that's a good question. So what you normally want to do for the cache is you normally want to keep it in its own dedicated partition. And so if that partition fills up, it's not going to, like, you could put the cache in your root file system, and that would make you sad. Right, so you don't want to fill up your root file system. So yeah, you put the cache directory in its own special partition. You can completely blow that away on a reboot because everything in there can be pulled back if you need it. And AFS, I didn't talk into details how this works, but basically every file has this version number thing. So we have a version number on every file. The file servers store a version number, and the cache files have the version number in there as well. So what happens is when the client starts up, it looks at that version number to it goes to the server and says, I got version 3, what version do you have? And if the file server says, I also have version 3, then the client's smart enough not to have to download it again. So the other issue is, what if I have a file that's really big and it won't fit in this cache partition? Am I out of luck? And the answer is no, because what AFS does is it stores the files in the cache in chunks. So actually, if you look in the cache, you don't actually see the files. You see data chunks, and then it kind of recombines those, and it's kind of like packets on wire, if you will. More questions?
Does it work well in a low bandwidth situation?
Probably not. So does AFS work well in a low bandwidth situation? And I said probably not. The reason I'd say probably not, because one, it's a network file system, so you want it to have, so any network hiccups is going to impact the file system, right? To the users, they'll see it'll be slower. More importantly is latency. If you have really poor latency, that will be more noticeable to users than slow bandwidth. Yes?
Hi.
Hi.
So from a security perspective, it seems like everything was bolted on. You had underneath a strong protocol for doing massive distributed file distribution, storage, and transmission, but you don't have a whole lot of security built into your package or line and other stuff. Is that my correct understanding?
No. So the question is, why is security so bad in AFS?
Awesome, sir. Okay.
And the answer is, okay, so there's two layers. One is AFS uses something called Kerberos for authentication. And Kerberos, originally when AFS was written, they shipped their own version of Kerberos version 4, which was DES-based only. All right, so DES is obsolete. So back in the 80s, we knew it was going to be obsolete. In the 90s, it was bad. Now you can crack a DES key for $20 or something. So we use Kerberos, and that has strong authentication. That is vetted by security people. So we let them do that. The parts of encrypting stuff on the wire, the work that there is native encryption for that. Now, if you want to, you can tell your client, I want this stuff to be encrypted. But the problem is that's also DES-based.
Okay.
So that's why we're developing something that uses something called GSS API, which is a security library that uses strong crypto. So in a way, yeah, we're basically going to leave the cryptography to the cryptographers.
Well, that's what you should do.
Thanks. That's the idea. Yeah.
I had two more questions relating back to the file storage. Is there any sort of versioning control in case the file gets corrupted? You can step back to a previous version of the same file. And then secondly, is there any sort of compression or anything like that to maximize disk space utilization for, say, raw text files or anything like that?
So the first question was, is there any kind of versioning within AFS to back up if something goes all wonky? And the second question was, what about data compression? So the answer to the first question is no, that's not done within AFS. We do have data versions of the files, but that's only really for synchronization between the clients and the servers so that the clients know they have the right file. If they have the wrong file version, they go and fetch the data for the version that's on the server to give the user the right data. But that's not used for, like version control, if you will. Version control would have to be done by an application. And the second question is compression. So AFS doesn't do compression or data duplication itself, but the underlying file system that stores the files can. In fact, some of our very largest sites that are running AFS run AFS on ZFS expressly for data compression and deduplication. So the files themselves underneath are in ZFS. AFS is blissfully unaware. It's just, so that's outside the scope of the file servers, really. Yes. Yes, sir.
So, you mentioned AFS before.
Mm-hmm.
How do you feel OpenAFS compares against other stuff in this class, like CEFFS or Tahoe, Authority File System?
Well, I'm not an expert in any of those things. Oh, the question is, how does AFS compare to other distributed file systems? So, so I'm not an expert in those systems, but I know, like, for example, CERN is using CEFFS now quite heavily. And they say that there's certain things that it still doesn't do as well as AFS yet, but it's getting there. So yeah, there's a lot of things to choose from. One of the things that AFS doesn't do well at is like clustered file systems. So although people do use it for that, and actually CERN tells me it works well for them for that, but other sites will say like they will use Lustre over AFS. But Lustre is more, the use case for that is more, I have a data cluster and I have a lot of programs hitting the same data set concurrently within a cluster. AFS is more of, the use case is more a general, is meant to be more of a general purpose file system where users can be more geographically dispersed and the data is not necessarily like all within the same data center. It can be spread out across a lot. We have a lot of sites that have AFS running in data centers all over the globe, but within one cell, for example. So it's kind of a different use case than that. I think a lot of the new file systems that are coming out are really based more on clustering and those kinds of things. Yeah. Go ahead. Yes. Well, the question is, will AFS work over a site-to-site or a VPN over the internet, for example? And yes, that's how it's used quite often. Yeah.
Can portions of your file system be read-only, but other portions be read-write while in reverse in another location?
No. So the question is, can portions of the file system be read-only and portions be read-write, but in another location not be that? And the answer is no, because we present a unified file namespace no matter where you are. So if I'm on, that would be a bug, basically. So if I'm on one machine and I see a file, I go down a certain path, and that file is, and by the way, the delineation between read-only and read-write is based on the file path. So if a file path is a read-only file path, then it should be that for everyone in the world. Okay, go ahead.
I was getting that kind of concept of like a branch office location where they have access to specific folders, but they can't change the root. But maybe in the central office, you can change files at the root, and then it would be invisible to the branch.
So yeah, the question is like, setting up different locations have different access requirements, and that to me sounds like it would be like access control management. So I would set up like groups. I'd say like central office group and put those people in the central office group, and then the branch people, I'd have a branch group and I'd put them in the branch group, and then set up the access controls correctly so that the branch people can read and write the files that are branch people, and so on and so forth. So yeah, and that's one of the really good features of AFS, is that it forces you to think about those things ahead of time. So like when you're rolling out like NFS 3, for example, you don't think about these things until it's too late. Anyone else? Yes, in the back? I'm sorry, I couldn't hear the question.
So what does the AFS value look like on the server's storage?
Oh, what does the file look like on the servers? Okay, so like I said before, that in the clients we have this thing called cache. We have in chunks, but on the servers, actually, we're storing the files as files, whole files. So like if I have a 3 gigabyte, MPEG file on the server, it's going to be there's going to be a 3 gigabyte file somewhere. It won't be the same name though that you would see in the tree. I mean, there's an encoding for what the name is, because there's a lookup based on something called an inode number. So we have an inode number, and we got to look up what that file is. The file name isn't on the server; it's buried somewhere. But the actual file itself, will be a whole file on that server in the partition. And you can actually, if something goes really wonky, and this happens sometimes, we have tools to go back and find those files on the servers and pull the whole file out. Yes, go ahead.
By extension, you have a file stored on AFS that's larger than any single file server.
Yeah, you couldn't have a file that's larger than any particular partition on a server. That's correct. And the other point is that the files all belong in volumes. The volumes are not split across servers. That particular volume can grow or shrink because it's just a set of files, but that set of files has to be on one particular server. Go ahead.
You said that AFS doesn't care about what the host file system actually is on disk. Many file systems have differing file size limits. What happens when I have a file that's bigger on one machine in AFS than something else in that same cell can support? Do we have massive data corruption and everything fails, or does it recognize that, hey, this sucks and you should get a different file system?
So I think the question was, what happens when you have OS-based limitations? Because AFS is supposed to be cross-platform. So what happens if I have a file that's way too big for a particular client? So basically, how do we deal with interoperability for those kinds of issues? And that's a good question. Think about that one. Yeah, I think realistically, you would hit. I think realistically or practically, we would hit limitations within AFS itself before you hit those types of limitations. Any other questions? This is a good set of questions. I'm gonna write these. Someone recording this? I gotta write these down.
As a matter of fact, I think they are.
Oh, okay.
When you repeat the question and speak into the microphone, both things happen.
All right. Well, if nothing else, then.
Here's the 9 minutes left. Anybody's question?
Any other questions? Oh, yeah, go ahead.
What does the management interface look like for managing this? Is it like a web-based interface? Or do you have to
Oh, command line, baby. It's all command line. So, yeah, this is one of the things that oh, the question is, okay. The question is, what's the management interface for this stuff look like? And so yeah, it's currently all command line, which I assume people at Notacon would actually appreciate. So actually, I do have there's some stuff on GitHub that's like add-on to AFS, and there's a web-ish interface that actually I'm working on and some other people are working on, but only because for some reason people think that the command line is evil. I don't know why. They think it's broken, but basically everything in AFS is a command line base, which actually gives you a lot of power. Really, it does. It's actually, I think, a benefit, not a drawback. So the command set is actually pretty good, I think. There's a command set for managing the server processes themselves. You can start and stop services. So like a lot of the stuff was actually invented before SSH. So there's everything you can do on the command line. And you can start and stop processes. You can move volumes around. You can create snapshots of volumes and all these things. From the client point of view, there really isn't any interface because from the client's point of view, it's just files, right? There is some command line-ish stuff to like set access controls and things like that. Yes?
Do those access controls differ significantly from the like CH1 type interface that we're using?
Oh, so the question is, do the access controls... Ooh, thanks for the positive feedback. So do the access controls differ from what the normal Unix user bits that we all love and are used to? And yes, they are different. There's some same idea, but so what happens is AFS can't trust the Unix mode bits. It basically uses these access control bits, and the bits are basically, can I write to the file? Can I read to the file? Can I delete the file? There's only like, there's not, can I execute the file? And those are the main things. It basically comes down to like read access versus write access and execute access. So it is different than the mode bits, but it's pretty simple actually. And I think that's actually one of the plus sides to AFS is that they didn't go overboard on the access controls. They kept it very simple on purpose to make it more manageable.
Here's a follow-up question.
Yes.
If I set the Unix side access control bits on files, will those same bits be set on those machines?
Yes. So the question is, if I set the Unix access control bits, will those be reflected across the AFS namespace on other machines? And the answer is yes. So AFS stores not just the file data, but the metadata for that file. So it stores the stat information. So like the user, owner, the owner of the group, and the mode bits, the creation date, stuff like that. Yeah. Yes.
What if you have a site that doesn't already have a Kerberos server? Is there a particular Kerberos server implementation you can go for?
Yeah, so that's a good question. So the question is, what if I don't have Kerberos already? What's a good way to go? What's a good way to start with this? And that's kind of like why I kind of harped on having Kerberos first, because this stuff depends on Kerberos, and that's a prerequisite. So it depends. That's really it depends on. It comes down to, do you want to do a Unix-based Kerberos or a Windows-based Kerberos? If it's a Windows-based shop, then you go with Active Directory. You just use Active Directory. And if you have access to the Active Directory admins, so they can make changes, so they can add users or whatever, make the service, whatever they do in Active Directory, they click on something, I guess. Then that's the way to go. If it's a Unix-based shop, then you want to probably use something like MIT Kerberos, which is like the main Unix flavor. There's also a Heimdall, which is a variation of that, which is developed in Europe. I guess, can you turn the camera off? No. Yeah. No, I was going to say something. I didn't want to record it, but.
Oh, it's like 20 minutes of questions.
That's good, yeah.
So thank you very much for the questions and the attention. And if you guys have any questions, I'll be here hopefully for a while, and hopefully sometime tomorrow if you have any more questions.
Can you put that up the screen that has like your end talk?
That was recorded.
What was that?
So yeah, that's my email. That's my information. There's also I put the slides. Oh, you can't quite see it here. The slides are in AFS, of course. But also, if you have a web browser laying around, you can find them. I have a site called meffie.org, and there's a link to them there as well. So thank you.
Thank you.